Yeah, so uh, what we know from oncolytic viruses that doesn't have payloads is that, uh, well, there hasn't been huge clinical advantages. You can kill tumor cells with oncolysis alone, but the problem is that it doesn't really matter what virus you have, but eventually you will have the immune system attacking the virus because that's what the immune system do. It's supposed to protect us against viruses and other intruders. And if you have an oncolytic virus in a tumor, uh, eventually the immune system will just kill all the viruses. So then oncolysis will not be enough. And even if viruses can trigger also immune responses, it's not really enough. And during my presentation, I will also show you how much immune activation will you have from the virus if you don't have any transgenes compared to when you add transgenes. And then you can really see that you have a log influx of co-stimulatory molecules, cytokines and chemokines. So I do think that oncolysis is interesting uh, to have oncolysis to release antigens, but the transgenes are important to get a really good immune response that is tweaked to the T cells. But something that I realized lately is actually that when the virus is replicating, then you also replicate the DNA in many copies that will translate into even more mRNA for the transgenes. So if you have a replication competent virus, you will have more transgene and higher transgene expression on the cells compared to if you would have a replication deficient. So I do think that the combination is better than either part alone, even if an oncolytic virus that doesn't have transgenes would work perhaps better in a setting where you have a localized tumor, like in the brain, a glioblastoma, for example. I think that's a good tumor for a virus that wouldn't have any transients. You might not want to have the massive inflammation and so on that can be difficult to handle in the head and in the brain. So I guess you need to find the best virus for different tumor types.